Welcome to metric prefixes. So if we have extremely large or extremely small numbers, we want prefixes larger than kilo or smaller than milli. We've already talked about the prefixes between kilo and milli in the last video, so if you need to, go back and review that one. So here are some other prefixes. Let's start out in the middle at our base. Our base would be here at this point. So everything below the line is a smaller unit. Everything above the line is a larger unit. So let's start with the big ones. So a kilo, we have already talked about. Kilo is 10 to the 3. So a kilometer is 10 to the 3, 10 to the plus 3 meters. A megameter, note that this is a capital M. And note that all of the big units have capital letters. They've got big letters for big units, except for kilo for kilometer. Megameter is 10 to the plus 6 meters. That's 1 million meters. A gigameter is 10 to the plus 9 meters. That's 1 billion meters. Tera is, again, 1,000 times larger than giga. So a terameter is 10 to the plus 12 meters. That's a trillion meters. Then as we go small, we've got decimeter, which we know is 1/10 of a meter. Centimeter, which is 1/100th of a meter. A millimeter is 10 to the minus 3, or 1,000th of a meter. We've got a micrometer, which we symbolize with this strange looking letter here. This is the Greek letter mu. Mu is how we write it. It basically looks like a U with a tail on the left side. So that's mu. So micrometer is 10 to the minus 6 meters. That's 1/1,000,000th of a meter. We've got nano. So that's symbolized with a lowercase n. So a nanometer is 10 to the minus 9 meters, or 1/1000,000th of a meter. Then we've got pico with a lowercase p. That's 10 to the minus 12. So 1 picometer is 10 to the minus 12 meters. And in chemistry, these are basically all the ones that we use, where most of the ones that we use are kilo, deci, centi, milli. We do get down here to micro and nano as you start getting a little bit more advanced. But generally, if we need to go smaller than that, you're either in a really advanced chemistry course or you're just talking about something outside the scale of atoms and molecules. And so generally, we don't use those in chemistry. So note that aside from deci and centi, all of our metric prefixes are abbreviations of powers of 10 that are divisible by 3. So let's go back. So tera is 10 to the plus 12. 12 is divisible by 3. Giga is 10 to the 9. 9 is divisible by 3. Mega, 10 to the 6. 6 is divisible by 3. Kilo is 10 to the 3. So again, ignoring the centi and deci, so ignoring those two, we have all these others, 10 to the minus 3, 10 to the minus 6, 10 to the minus 9, 10 to the minus 12. Those, again, are just the mirror images of these guys, where these are the positive exponents, these are the negative exponents. So these are the large prefixes, these are the small prefixes. But all of them, except for deci and centi, are divisible by 3. So for the prefixes above kilo, the abbreviation has to be capitalized. If you have, again, let's go back. If you don't write mega as an uppercase m, then it appears to be milli, which is the lowercase m. So again, all of the big units except for kilo have to be capitalized. For prefixes kilo and below, the abbreviation must be lowercase, because if you capitalize milli for millimeter, you've now turned it into megameter. And so you've changed what that prefix is. So a metric prefix is interchangeable with the exponential term that it represents, which means that an exponential term can be substituted for a prefix. So if we have something like 7.0 millimeters, we can write that instead as 7.0 times 10 to the minus 3 meters. If we have 5.6 kilograms, we can write that as 5.6 times 10 to the 3 grams. Remember, 10 to the plus 3 is the meaning of kilo. 10 to the minus 3 is the meaning for milli. If we have 43 nanometers, we can write that as 43 nanometers, or 43 times 10 to the minus 9 meters. Alternately, a metric prefix could be substituted for its exponential term. So if we have 3.5 times 10 to the minus 12 meters, we could write that as 3.5 picometers or 3.5 pm. If we have 7.2 times 10 to the 6 watts, we could write that as 7.2 megawatts or 7.2 MW, where both the M and the W are capitalized. Again, if we write this M as a lowercase m, then it will be milliwatts. And so we've drastically changed the number over there. Note that computer science uses slightly different prefixes than science does, because computer science uses prefixes based on powers of 2, not based on powers of 10, as we use in science. So this means that in computer science, kilo means 1024, so 1024. It doesn't mean 1000. And other prefixes differ as well. So a giga is 1024 mega, whatever. So if we have 1 gigabyte, that's 1024 megabytes. 1 megabyte is 1024 kilobytes. 1 kilobyte is 1024 bytes. If you've memorized how to convert the computer science prefixes, you're going to have to use a slightly different definition here for the science ones, or you'll be off by 2.4%. So you need to memorize the prefixes in the table presented above so that you know them without doing the calculations. To help you memorize, you need to practice writing the table from memory. So to help you memorize, look for patterns and use memory devices. It might help you to remember that tera, the top one that we have, T, which is 10 to the plus 12. Nano, which is a lowercase n, is 10 to the minus 9. So 12 starts with T just like tera does. 9 starts with N just like nano does. And again, remember that nano means small. So these two can help you sort of anchor the table, and then you can fill in the prefixes around them. So if you can remember the order of the prefixes, that can then help you fill in the equalities or the exponential terms that go with each of the prefixes. So draw a table 3 columns across and 11 rows down, and then in the top row write prefix, in one column abbreviation, in another column and means in the third column, and then fill in the table. And repeat this until you have the table of prefixes memorized, and then, and only then, do the practice problems in the book. So we often need to convert between different metric prefixes when we're solving problems. And we've learned 2 types of equalities. We've learned our meter stick equalities based on what 1 unit is equal to. So these are 1 meter is equal to 10 decimeters, which is equal to 100 centimeters, which is equal to 1,000 millimeters. And we've also learned our prefix definitions based on what 1 prefix is equal to. Like nano is equal to 10 to the minus 9. So 1 nanometer is equal to 10 to the minus 9 meters. So you need to be able to correctly use both forms. So when converting between milliliters and liters, you might see 1 milliliter is equal to 10 to the minus 3 liters, based on what milli means. Or you might see 1,000 milliliters is equal to 1 liter, based on the definition of 1 liter. And note that both of these equalities mean exactly the same thing. The second one simply has both sides multiplied by 1,000 compared to the first one. Note here that 1 milliliter is equal to 10 to the minus 3 liters, and 1 liter is equal to 10 to the plus 3 milliliters. So the number involved here is the same. It's just a matter of whether the sign is positive or negative in that exponential term. And this is the catch, is that if you switch these, then you're going to be moving your decimal the wrong direction when you're doing your conversion. So you need to be really careful with these and get really comfortable with these. So you need to memorize the equalities first and then apply them. So the sign of the exponent changes depending on whether the 1 is in front of the prefix or in front of the unit. So which one do we use? The book generally uses the one prefix equalities to solve problems because you should have those memorized already. You should have memorized those as we said earlier in the video. I, however, am going to use both types of equalities, but I tend to use the one unit format more often. So this is something like 1 meter is equal to 1,000 millimeters. Or 1 liter is equal to 1,000 milliliters. I don't care which format you use, but you need to be able to use the format that you choose correctly every single time. So pick a format and stick with it. So you can generate the one unit format from the one prefix format. For example, 1 gram equals how many micrograms? You should pause the video and fill in the answer yourself. So from the prefix table, you know that 1 micro anything equals 10 to the minus 6 anythings. So 1 microgram equals 10 to the minus 6 grams. So 1 microgram equals 10 to the minus 6 grams. If we want to get 1 in front of grams here instead of 10 to the minus 6, we need to multiply both sides by 10 to the plus 6. So 10 to the plus 6 micrograms is equal to 1 gram. So in there we can now write 10 to the plus 6 micrograms is equal to 1 gram. We can summarize this as if one prefix equals 10 to the a, then 1 unit equals 10 to the minus a prefix units, where unit and prefix can then be replaced with any unit and prefix we know. So to change a prefix definition between the one prefix format and the one unit format, change the sign on the exponent. And then you can check your logic by using an example that you know. So you know that 1 milliliter is equal to 10 to the minus 3 liters. So 1 liter equals 10 to the plus 3 milliliters. So that was metric prefixes.